Hey, I'm Brett, Useful Aircraft. I love the planks. Why? They're simple. Look at it. 2 servos, ESC, motor, and a receiver. In this case, also incorporated the DJI O4 FPV system and a couple of my Nerf dart drops. But this airplane is something that you can put together in about 30 minutes and have out at the park and fly. It flies like a plank. That's a flying wing with a fuselage. What's that mean? In lieu of having a tail surface, which provides additional pitch authority, the elevons are doing double duty both as ailerons and elevators. So this will not be the most maneuverable airplane when it comes to pitch. However, there's really not a better or easier to build design if you want to go a long distance efficiently and capture it all with a Beauty FPV. So let's get straight into it and let's start building an FPV plank. These are the parts we're going to use. This is the wing, the fuselage, the forward closeout, including the camera mount and hatch. This is a fuselage doubler, which reinforces the aft fold line and provides separation for our GPS and our high current wiring. Aft fuselage closeout, and finally, our vertical stabilizer. 3D printed parts will include our vent latch, which doubles as providing cooling to any installed avionics and providing the latch for the forward hatch. This will be the DJI camera mount that I've built, 3D printed and designed for an O4 or the O4 Lite, as some folks are conventionally referring to it. And lastly, these are flight control horns. If something you're interested in is the Nerf dart aspect, you can 3D print this mechanism here, which allows you to bolt a servo, little piece of fishing line, and it gives you a Nerf dart release mechanism. Let's get about to building. To start, we'll start with the wing. Move my other components out of the way. The wing itself, this is the underside of the wing. This is the KFM fold, which will fold over. So this will be the top surface of the wing. These lines here show the fold area. I use my foam board tool, which is a 3D printed tool, also available on my website, usefulaircraft.com. And I'll use the wide foam roller with offset scalloping. Place this right where the fold lines are. And let's run that line from one side to the other. Just like that. Now we're ready to fold the leading edge over and close out our wing. A little bit of hot glue. Might need a new stick there. Putting some hot glue in the fold itself. And then on the undersurface of the fold step. Should be good. I'm going to use my 1, 2, 3 blocks. You can use books, you can use bricks, you can use any tools you want just to apply some pressure on the fold. Fold the leading edge over. Let's place our 1, 2, 3 blocks in position. And that should be good. We'll allow the hot glue to cure, and we'll move on to the next step. So again, on the foam roller tool, that's the narrow side of the foam roller tool. This is the wide side of the foam roller tool. I made these tools myself. Previous design found on Thingiverse, I really enjoyed this. However, I noticed the scallop positions on the cutting wheel were in line with one another. So material that was compressed was basically 2 scalloped halves were directly opposed from one another. And so areas where foam remained in a fold would be forced to compress, and you ended up with artifacts in that fold area. What I did is I took the two scallops and I offset them by 50%, so the remaining foam here will tuck into that area and the remaining foam here will tuck into this area. So again, this allows me to use this scallop tool, and I'll run down my elevon hinge lines. Same thing. There we go. And this will provide some really nice hinges that'll work well on our wing. Our wing is remarkably almost done. Pull our 1, 2, 3 blocks out. There we go. And here you can see this is an Avionics access pass-through, also used as a vent. These will be our center of gravity marks, and these are alignment cutouts used for the teeth in the 3D Nerf dart drops. You can see those there. So this will allow this to clip in. Remember, this is the undersurface of the wing. Flip it over. Here's the top side of the wing. Grab our flight control horns. Break that sprue. The sprue is completely artificial as these are 3D printed. These flight control horns will be installed from the top side of the wing down, just as such. And if you notice, the large offset side here is going to be aligned outboard with the wing planform. The pass-through holes here in the root of the flight control horn are for hot glue to go through, and those will keep the flight control horn pinched, as those holes will be on the upper surface and lower surface of the wing. You'll see what I mean here in a moment. So I put them in so I know the orientation I want them to be in. Take a little hot glue, run it a beam, that 20mm cutout that is just next to where the flight control horn itself passes through. Lift my wing. Again, this is the upper surface of the wing, and I'll fold these into position as such. In doing so, you'll see a little amount of hot glue is passing through those holes there, which will help to keep those in position. On the undersurface, you can see there's the flight control horns, and you see those holes right at the root. That's where we're going to pass a little bit of hot glue through. So, just to the center. There we go. And same from the other side. So again, now if you look, you can see a small bulge of hot glue passing through those pass-throughs at the bottom of the flight control horns. I'll set this aside to rest because the wing is done. Let's talk about the fuselage. This is the fuselage here. These are going to be our fold lines as well. I've used the laser to score 50% of the way through the foam board. And what's going to happen is we're going to break these open, and I'll use the edge of the table to do it. If you're hand cutting these, you can simply use a razor blade in order to trace that line and cut 50% of the way through. Or at the same time, you could use the foam board tool and break that edge as well. So what we'll do, I also should point out, there are some index marks on this. The index marks, I'll see if you can see them here. They're 2mm cuts starting, this is the wing leading edge as it'll be placed into the fuselage coming back. The first one will be the center of this vent hole. The reason being is we use that to pass through our flight controller data bus for programming the flight controller. So that'll be what this center tick mark is, as shown here. Aft of that is a glue stop point. And again, little mark, it's 2mm cut in the foam board at 90 degrees to the cut line longitudinally. And that tells you to stop gluing from that point aft to the servo tab, because this will act as a wire pass through for servos for the Nerf dart drop mechanism, if that's something you want to incorporate. Moving aft, another tick mark here. This tick mark is to show, this is actually the fold line. Behind that, this tick mark shows the aft of the wing center section. So that will install and show where this tab comes to an end on the fuselage. Again, these are put in there so you have a reference for, you know, at different stages of the build process where you want to glue. Next tick mark here is at the very back, and that gives you an idea for the motor mount, where the motor mount should end. And to show you that, if I hold the motor mount up along there, you can see that that'll be approximately where the glue should end. So again, as you go through the build process, keep those tick marks in line, and that'll let you know what we're using those for. So we'll take this, move the camera a little so you can see, bring it to the edge of the table, just like this. A little even pressure and that snaps right over. Do the same for the other side. Edge of the table, little even pressure, snaps right over. Now, the fuselage should look like this at this point, where we can bend it over. We're going to close out the back end. In order to do that, we need to bend these fold lines as well. Edge of the table, and just a little gentle pressure, and they bend down as such. I'll use a couple more of my 1, 2, 3 blocks. Here we go. Frame them in position. Come back to the tail section along here. And I run a bead of hot glue, probably 3 inches along the lower fuselage skin, the outer sidewall where the fuselage sides will interface. So, a couple of beads of hot glue. I started at about this aft vent hole here, the third vent hole, and now rotate these back, put the tabs into position. I'll put a little weight on this, and a little weight to hold this closed. Let's give you a tour of that. So this is what we're looking at. You can see the hot glue was run from this hole aft. The fuselage is fully tucked at the back end. And this is what we're looking at. Pretty straightforward. Let's go ahead and return to the build surface. And that should be pretty close to being cool. Little tactile check. Seems good to me. Take our motor mount. This is the motor mount. Again, as you can see, that's a 1407 3500 kV motor, and Gemfan 3052-3 propeller is what we're using. The ESC, put my goggles on. It's showing a 3S LiPo. This is HGLRC ESC. I do not run a BEC because we're going to be installing a flight controller in this build. So let's go ahead and put some hot glue. Again, I'm looking for those aft index marks, going from that point all the way to the tail of the ship. I don't know, looks like probably a 30 millimeter run or thereabouts. And now I'll take my motor, ESC, and all of that wiring. I'll run that into position. Now let's find a way to prop this up. The motor as she sits, there we are, and I'll show you this. The motor has a little incident built into it. It's pointed towards the aerodynamic center of the wing to help reduce any pitching moments during power applications and whatnot. So again, that's the motor mount, and those files are included in the in our file drop. Let's go right back to the build. So we've got that in. Next, we want to install some avionics. But before we put that in, what we should do is we should reinforce this aft fuselage bend area. On a completed airframe, to show you where we're talking, it's these lines here. Those are the cut lines that we used on the fuselage skin in order to taper the fuselage back to the motor, which makes this a lot quieter running ship and gives it a little bit better efficiency. But what we're going to do now is we're going to reinforce that area there. And the way we're going to do it is we're going to make a little step table. So you have this piece here. Break those two edges like that. Little hot glue on the side. And this will be installed right at that fuselage taper line. I span that fuselage taper line. I try and go about 50% on either side, and I'll show you when we get this installed. So again, just look for where that bend is. I pull the wires taut underneath, and that should work just fine. We'll bring you in and have you take a peek at that. Put a little extra hot glue on here. Again, this is not an area that I spare the horses. Run a bit extra bead there. You're holding that fuselage skin together. Let's take a look at that. So there you can see that table as it's installed. You can see I pushed a little extra hot glue in there, and these are the cuts. You can see where the paper's been cut about 80% through by the laser, and that allows me to reinforce that area. And also at the same time, it allows me to keep the high current wiring that's running back to the ESC separate from where we'll install the GPS later. If we're worried about that piece floating, we can put a weight on it. That wasn't the greatest idea. The weight touched a piece of the hot glue, the weight obviously being much cooler. The hot glue tried to adhere to that. Either way, managed to pull that out. We'll just let that set and cool organically. So we're in position there. Let's go ahead and install the flight controller. For the flight controller, I'll show you back down to the work surface. There we are. The flight controller, I'm using an F405. This is the Wing Mini, built by Speedybee. I have a top index mark. Again, all of these files I'll include if this is something you're interested in building. But basically you have the battery input here. This will be the output to the motor. This will be for the DJI camera feed. This is obviously M10 GPS running to the stern. We have if I can untangle this to some extent, a Maytech receiver running diversity for ELRS. Things to remember with this, obviously you'll want to get in and program it subsequently. I like to build and set up and test all my avionics before I bother to install them in an airframe, and they should be checked and everything should be run, and I have done exactly that with this. But ultimately you will always need access to the programming port. The programming port has the word bar written on it, I think because it drives you to go to the bar after you've spent a few hours getting frustrated. But I've put a T on here to indicate this is the top surface because we're going to mount this to the side wall of the fuselage. Remember when I talked about those index points? What we want to do is we want to get into the center of this vent. The reason being is to program this flight controller, I use this tool here. I've taken a popsicle stick. There's my USB programmer. And I've simply, that's a heat shrink, clear heat shrink, adhered that cable and a little bit of hot glue to hold that right at the end. There we go, probably a little better focus on it. And again, the idea being I can reach through that hole and that'll plug straight into there like that. And I can run my USB programming. In order to do that, I needed to know where the center was because the center of that hole needs to line up with that cable. Furthermore, I'm going to go ahead and plug in my ESC to the power. There it is. GPS will run aft. These cables, I want them to go aft. And then lastly, I want to plug in the ESC's throttle signal to, not the S-bus connection, but actually throttle position 1, S1 I believe it's called. So I've done that there, and let's not make that mistake. Let's go ahead and make sure that the way that I've installed this, you want to make sure that the ground line obviously is installed correctly. So we're in good shape. These cables run forward, everything else will run aft, and we have our center mark here, which we want to have a line with that. Hot glue, little hot glue on the back. You don't want this coming loose. Anytime a inertial reference unit on fixed wings or quads comes loose, you're in for a really bad day. So now I'm taking the that data port and making sure it lines up directly with this cutout. If so, that should put it in the center of that vent and allow me access to that. So I'll hold this in position for a moment. And next we're going to start thinking about how we're going to run our wires. Pull the weight off of our motor mount. That guy is secure now. Tap this wiring down. And what I'm going to do, I typically like to have my ESC wires, especially the high current wires, I like to make sure that I'm keeping those as clear as I can of any of the other data lines coming off the receiver or off the GPS. So I think this guy's adhered. Yep, it looks good. The two servos, we will spread these. This is the lower, so that'll be the left. The upper, that'll be the right. Fuselage forward. So the antennas for the Maytech unit, I'll thread these aft just while I have access here. Very well. And touch of hot glue. Well, let me do a touch of hot glue back here. What I'm going to do is just to get those wires running to the ESC. A lot of current going through there, and I want to keep that separate and away from everything else that I can. So I'm going to hot glue this so it just stays in the corner. Remember, when you go to remove any hot glue, a little bit of isopropyl, just, you know, I use 91% rubbing alcohol, and that will get the hot glue to release pretty much instantly. So there we go. You also notice that some of my cables, for example, these power cables, I'm using dental rubber bands. Those are dental rubber bands. You can find them cheap online. But they work well to help tidy up your wiring. So these antennas for the ELRS unit, I want to have these coming back just as we do. And again, how you run your avionics is entirely up to you. But as you can see, that'll pass just by that vent, keeping some cool air flowing on it. Lastly, I want to run the GPS, and the GPS that I'm using, I usually glue it just on top of that pad. Everything above it's going to be foam board. So there we go. Little hot glue on top. It's the Flywoo M10 GPS. Drop that into position. There's no compass. It's something you may want to consider whether or not you want or need a compass. You know, there are applications where a compass is handy. You know, otherwise you wait on ground track in order to determine heading. But it's something for you to consider in your designs and builds. So that should go relatively quickly. Now let's go ahead and place the servos. These are the servo cutouts here. A little bit of hot glue inside the recesses. Just like that. And just like that. I have my servo wires escape forward, as you can see. Same thing on this guy. Servo wire escaping forward. Servo in place. Tuck that wiring as you like. I'm going to use a couple of 1, 2, 3 blocks just against the servo actuator itself to gently hold that in position, and this weight to hold pressure on the servos, so this keeps them secured in the side and in place in the fuselage. Where we stand right now, we're in a good place to begin testing your avionics for your integration. As I have tested mine plenty before we put this together, and for the sake of this video, I will go ahead and continue with the build process and show you the rest. While we wait for this to cure, what we'll do, take our forward fuselage closeout, just like this, and again, between these lines here, I'm going to run my crush tool. We'll watch this. That's the narrow end of the crush tool. This is the wide end. Take the wide end, crush that. You can see what I talk about with that offset scallop pattern, or hopefully you can. There you go. That's a better view. So with this being the crush side down, a little bit of hot glue in there. Fold this over, and we'll hold that in position as that cures. So at this point, I'll just tap and secure one of my antennas. Make sure my servo wire is not crossing my GPS. Do some wire cleanup before you close out your fuselage. This should be good. And little bit of hot glue down there. Tap one of these antennas running longitudinally, fore to aft. Hopefully that's correct. That holds in place. The other one, we can just poke it out through these holes back here. That way the two are at 90 degrees to one another. I just want to verify on that. That may or may not be a great idea. Actually, that's problematic. We're going to have to run it through the second hole, not the third. The reason being is the tail. I just checked my aft fuselage closeout. There we are. And again, you can fit it here. You can see the aft fuselage closeout runs roughly from these index marks as we previously discussed, and I can look straight down and I can see that I have a straight shot to glue my my rudder on. So actually at this point, with these antennas as we want them, there's no reason we can't go ahead and close out that top plate. So again, I'll go for my index mark aft, index mark aft, just like that. Aft fuselage top plate. Make sure the wiring coming off the ESC is centered. It is. Passes through the semicircular pass-through there. Put this into position. And hold that down just for a moment. The DJI O4 camera system will be installed with the antenna coming through this hole, just as shown. A little bit of hot glue in there. Put the antenna through the hole. Make sure that this is visually centered and facing forward as such. And actually, that should be good. There we go, she'll sit like that. All right. We should be in good shape to go ahead and mount the wing. Let's give you a flyby real fast. Motor, ESC, aft fuselage closeout. You can see how I've arranged the ELRS diversity antennas back there. That GPS unit mounted on that reinforcement plate. The servos. And again, there's a shot of you can see the index mark that is centered on the data port. And then I have my wires run forward for my DJI FPV and for my battery hookup. So we should be in good shape. Let's go ahead and install the wing. Move those out of the way. The wing is aligned visually. Some folks don't have access to a laser, might be cutting these out by hand using DXF files to generate an STL and print out templates. So in order to assist with that, you have two alignment marks at the front. Those alignment marks will align with the sidewalls of the fuselage there. And at the tail end, obviously, this tab will be aligned with the leading edge of the aft fuselage closeout. So just for an approximation, this is what you're looking for. Just so you can understand, the glue lines will be run from, there are cutouts, obviously for the KFM step here, coming back to the forward servo tab. So we'll fill this with glue. Remember, this aft index mark in front of the servo tab is where you should stop applying glue. So if you later want to pass servo cables coming in for something like a Nerf dart release mechanism or whatnot, access to a receiver, you'll still have access. That's more for building an RC version, because with this, once you close out, it'll be very difficult to add any servos to your flight control board. So what we'll do is we'll position this. I do want to also show you, before we close out, these marks here are center of gravity references. Don't be as concerned about the weight. You'll be surprised what these can fly with in terms of weight, especially a 3S battery turning a prop like this and a motor combination like that. It'll carry a surprising amount of weight and drag. However, center of gravity is critical. You want to be within a few millimeters of those center of gravity markings no matter what. So a lot of care has gone into figuring out where those guys belong. So what we'll do, let's run the hot glue again from the forward portion of the KFM step cutouts. And yeah, it's an inverted KFM, but guess what? It's also a flat plate airfoil, so don't expect this to be an amazing glider, but it's remarkably efficient given what it is in cruise flight. We'll keep this indexed area clear. Glue I put on top of the servos, on top of that little tab, and then running all the way back to the aft fuselage closeout. Same thing on this side, all the way back, aft fuselage closeout. Now, this process is done visually. Line at the aft end, that looks good. Line at the forward end, that looks good there. Put a weight back here. Put a little heavier weight up front and hold that in position. We'll give that a little bit, and wait for it to cool down. Simultaneously, we'll mount the little rudder here. Some of these rudders, you'll notice there's a cutout here for the antenna. Remember at the leading edge of the aft fuselage closeout. I'll show you real fast. This cutout here, that's if you wanted to have that diversity antenna come up and appear on the top side of the fuselage. Instead, I've elected to have it simply inside the fuselage just like this for lower profile and less drag. If you bring it up here and have it come out, you're going to have to put a cutout in your rudder to accommodate that antenna. So it's an option, something you may want to consider. Flip this around, bring it back down. There we are. So for the rudder, we make sure that we are clear when we're looking down there. There's no wires impeding the installation of the rudder. And we'll put some hot glue along these tabs underneath the undersurface of the rudder. And then at the very bottom here, and I put a little bit on the side that'll be picked up as it scrapes its way in. So, I don't know, nobody really cares, but there you go. We'll drop this guy in place. Move that forward just a touch. And I use my maker's blocks, one on either side, just like this. At the same time, sorry about that, a pair of these just like that, and that'll hold that perpendicular to the table surface. Aligned, you make sure it's pressed down. That's why I love these 1, 2, 3 blocks. They're just really handy. So now, this is the camera and the forward fuselage closeout. This is where the latch is going to slide in this cutout here. I take my fingers and I'm going to pinch just right here and right here. The reason being is that makes it easier to slide this latch in. The latch all the way forward. Make sure my wiring is down. This is when you can plug in your camera. And this will simply be glued in position there. When it's glued in position, you can run that latch, and at the same time, take any straight edge. You'll see where the fold lines are up here. Place that over the fold lines, and there you go. That's broken that hatch free and correct. So when you just waiting for this tail to cure, that feels pretty good. Everything appears more or less square. So same thing, a little bit of hot glue on the undersides. And the underside. Flip this over. You do have access to plug those cables in. We'll wait and let that cure. The reason I'm not plugging the data cable here, let me bring this back up and we'll chat. A little bit more. There you are, I got to see all my chins. The reason I'm not plugging the data cable in, remember, these cameras get really hot when you're sitting there and you're programming, when you're running through flight control tests and everything else. And in doing so, that will be the last step before I take the airplane out and fly it. I've already bound the camera system to my account. I've updated the latest firmware. When I do that, I use one of these fans. It's just a couple 18650s I hot glued, stuck a momentary switch, and that allows me to just keep a breeze going on that on the DJI O4 air unit. The air units get extremely hot really fast. Out here, even in the air conditioning working in the house, it'll usually be less than 90 seconds before you get an aircraft processor overheat. So that's something you really want to pay careful attention to. Any advice I have, I'm running INAV 8. It's one of the later release candidates, whatnot. INAV 8s run really well for me. If you do have any problems loading the firmware onto the board, what I can recommend to you is using the Impulse RC driver fixer. That was key to allowing me to do the DFU update and getting INAV 8 onto the board. Once I had that, it's been flawless. I've been very happy with how it's been running. So what you end up with, and I'll show you some flight videos here. You know, I mean, this on a 850 3S battery, you'll end up flying for 12 to 15 minutes if you're flying conservatively. This is not a acro, low to the ground, yank and bank airplane. It's not one of those built for that. What this is built for is you want to go check something out that's a ways away. This is a great cruiser. Okay, here we are. Let's get ready and go for an airplane ride. We're in acro mode, 99% throttle. A throw, a bit of a roll, probably torque, and we're off. All right, let's talk about the on-screen display. At the top left corner, we got battery voltage. That's per cell. Below that is current draw, and then throttle position, as shown there with that segmented S. That is a manual throttle position. When it has an A, that is an auto throttle position. Continuing down the left column, you have our speed in kilometers per hour, and bottom left corner, milliamp hours drawn out of the battery. Top center column, let's talk about that. You've got a compass rose depicted across the top, obviously showing ground track. There is no compass in this aircraft, so it's just GPS track. Below that is a bearing pointer and distance in meters to home. Below that, in the center at the top, acro mode. That is our flight control annunciator, says what mode we're in. Bottom of the screen, the R8 Plus Papa Victor Quebec, as it was displayed for a second. That's the Google Plus code. Shows our position. That's concatenated only to show a handful of digits at the beginning of the initialization, or if you have an idea where you're flying, that'll take you to your exact and precise location with much fewer characters than a conventional lat long. Top right corner, we're showing our GPS with 8 satellites, 7 satellites. Not really 100% fond of this GPS unit. It seems to not retain satellites as well and not get as many. I don't know, I'm going to play more with the configuration. I've tried all manners of shielding and everything else, and I'm just not in love with this particular one. Below that, RSSI, and then DJI's on-screen display, a timer showing 1:44 right now. And then our altitude. Altitude is displayed showing 15 meters as we speak, and that's a beam your airspeed on the opposite side of the screen. This layout's similar to HUD found in the airplanes I fly for work. Bottom of the screen, bottom right corner, you can see the fly minutes, flight timer as from the time that we've armed the airplane, and above that, DJI's on-screen display showing battery voltage, your goggles remaining current, and then your video transmission megabits per second. We've flipped over to cruise mode right now. You can see the throttle annunciation is blinking there to draw attention that the computer has control over the throttles. That blinking will stop here in a little bit. So again, we're in cruise mode. This is where I typically do most of my exploration, cover any ground distance. The aircraft will maintain a GPS track and hold an altitude, as this is the first time we're putting it in. I like to test it and see that it works. I'm going to stay within the confines of the park. We're flying within a FRIA. Everything is good and kosher as long as we stay within this area. But this is how I experiment with things. Flipped out of that back into acro mode. And in acro mode, again, this is where you have full range of the aircraft, and back into cruise. Practicing with some of the mode enunciations and playing with the controls on the remote. You can see testing return to home at this point. The system messages appear in the center of the screen, as to be obvious. You can see we're en route to home, and return to home enunciated at the top, and the enunciation, obviously with the bearing pointer, as we're drawing close to the station, it's going to make a smart turn to enter the loiter. And here we've entered the loiter. We stay in this loiter for quite some time. Usually I use these loiters in order to get my goggles adjusted, maybe take a break, take a drink of water or whatnot. But in this case, you know, this being a first flight, I want to make sure that the return to home works. I want to see how I like the loiter diameter radius. The initial stock setting is for a 50-meter loiter. I tend to find a 50-meter loiter is a pretty wide loiter for what I need. I generally pull it back to about a 30-meter loiter typically. If you get too tight, the airplane ends up banking over too much, and your horizontal component of lift that draws you into the turn is taking away from that vertical component of lift. So the only way to maintain your altitude is by bumping the throttle. In doing so, that increased bank angle of that tighter radius draws your battery down a lot quicker. So that's those are the arguments for doing a tight hold above you versus loosening the hold up for perhaps some better endurance. So again, we're loitering here. First flight again, I'm just trying to get an idea of what how I need to adjust my current counter, how I need to see, you know, what the endurance of this airplane is. This is why I keep it relatively close. I'm keeping a better eye on the cell voltage at the top left than I am at the milliamp hour counter. The milliamp hour counter in the bottom left corner, I don't find that to be as accurate, especially early on. I know that there are ways to adjust that, but in the first flight, as I've tested the airplanes on the bench, I do tend to find that the voltage is more representative and more accurate. And I know the flat profile of the discharge of these styles of battery, you know, so I keep an eye on it. And right now we're entering the flat stage there, kind of in the 3.7, 3.6, and 3.5 range, where there's a whole lot of meat in that battery there. But once you start dropping off the back end of that, you discover that the power is not necessarily available in the event of a go-around situation. This is also why some of the VTOL designs I am not 100% in love with, because as you come in low battery towards the end of a flight and you transition to a vertical takeoff and landing mode, you go back to having all of your motors providing high current draw and your batteries falling off, and that just doesn't work out that well. So we've exited loiter mode after our first return to home test, have a little bit of fun. We're back in acro mode. I'm feeling my oats, go for a little bit of a tour around the park, getting an idea of the winds. The winds were, I don't know, between 8 and 12 knots coming out of the east-southeast down there, and so this is why in this direction you'll see the ground speed picks up. But I also feel some of the downstream turbulence, mechanical chop rolling off both the homes and the tree lines there. It wasn't the most stable day for flying. So again, we're just having a little bit of fun. I fly this segment until about 8 minutes, 43 seconds, which is when we'll flip back into cruise. What I'm really testing is some of the roll response of the airplane and the pitch response of the airplane. What you'll notice in a plank is that obviously your pitch and roll response depends on the airflow over your flight controls. Your ground speed, however, which is displayed on the screen, may or may not have anything to do with your airspeed. And that's largely to do with keeping situational awareness on where the wind is coming from. And the winds aloft are also very different than the winds at surface levels. So, you know, once in a while when you see me do a roll, oftentimes what I'm doing is in my head building an idea of what that roll response was like. And, you know, a full stick deflection, I have an idea of how quickly the airplane should be rolling. However, if I suspect that I am perhaps in a tailwind, which is inflating my ground speed, I will have less of a roll response. And if I'm being particularly cautious about that, oftentimes I'll make sure that I pitch up a few extra degrees so when I launch into that roll trajectory, as opposed to the nose dropping through the horizon and losing altitude, I've already started with a climb at the beginning. Here I'm also getting a feel, we're kind of in the middle of the flight, still in the 3.7 range on the cells, getting an idea of when I do come in for my approach to landing, because again, we're 7 minutes in, this is an 800 milliamp hour 3S battery pack. I want to get a feel for what the winds are going to be like down low. So I fly a couple of low altitude patterns and see which direction I want to land, because very much so where you find yourself sitting and where you feel the breeze coming across your face and you build a mental map of where that wind should be and how you should land into the wind, oftentimes you discover that that might not be the way that winds are actually blowing out in the field. It's just a gusty oddball day. So there's a couple of those rolls again in order to make a determination of what sort of response that I'm having input to airspeed. So now with a better feel for how the airplane's flying, I'll flip her back into cruise mode. And again, this is me taking a bit of a break in cruise. The altitude will be maintained. So there we're in cruise mode around 20 meters, and the plane will fly the ground track. I can adjust the ground track of the airplane by using the stick, and I can adjust the pitch of the airplane, same thing, as well, using the flight controls. So here I'm just dragging the track of the airplane around to keep it within the confines of the FRIA, staying inside the park. And this is quite a bit of time here. This segment of the flight, I'll stay in cruise, surprisingly, all the way up to 14 minutes and 56 seconds. You know, so for an 850 milliamp hour battery, that again, despite what the milliamp hour counter in the bottom left corner of the screen is showing, the cell voltage is still holding steady at 3.66 volts as we are right now, cruising at about 4 amps. And this is a very comfortable get out and see the countryside kind of pace. And again, early in the morning when you're not having any of the rolling and pitching turbulence that you're seeing here, this airplane is a great airplane given its performance for its size. For something that'll sit on the front seat of your car, it really gives you remarkable capability in terms to get out and go see things. And again, this is on a small battery. You know, that 3S 850 milliamp hour pack and flying the DJI O4. You may ask why we're showing you just the footage through the goggles. And the reason being is, you know, I'm not a huge camera guy. I'm not a huge post-processing kind of guy. You can see my video editing and all this stuff is somewhat minimal. I just want you to get a feel for what I'm seeing through the goggles. Obviously, anybody can take stuff through GyroFlow, and GyroFlow can perform some pretty remarkable enhancements with it. But this is the raw data on a somewhat windy, somewhat gusty day. You know, middle of the afternoon out here on a Phoenix, I don't know what we are, you know, late winter day. So again, we stay in this cruise phase. We'll carry this all the way up to almost the 15-minute mark. This is what the airplane is built for. I do notice that the altitude hold is coming a little bit unglued to some extent. There might be some additional training that I need to do. The satellite count, however, has improved, so I'm happy about that. But again, there's a lot of little updrafts and downdrafts out there. I've gone back subsequently and flown this airplane early in the mornings in the most ideal circumstance, and it seems to feel a lot more locked in. But again, that was not the intent of this. The intent of this flight was to get it out in real world, less than perfect conditions, and I wanted to see how she worked. So we're at 11 minutes, 29 seconds, 30 seconds there, still at 3.6 volts. This is, again, the middle of the battery, or the voltage per cell tends to drop somewhat slower. We're pulling only 3.5 amps as we're cruising along, and right around my 30 kilometer an hour mark. That seems to be a fairly good speed for this, for zero winds, in terms of its minimizing your power consumption for the number of miles you're covering. So this is to some extent what I'm working with, you know, in trying to figure out how this airplane flies and get a feel for its range. I want to make sure that obviously it can fly well in acro mode, so if I need to maneuver it close to the ground, bringing it in, the performance that I can expect. But at the same time, the return to home, essential to test, as we did earlier on, to make sure that the airplane makes the turns in the right directions and follows the return to home settings that you have set up with regards to perhaps climbing first versus turning back on course, your return to home altitude, and then entering a loiter back over where you are, and then any landing settings you may have thereafter. I have not experimented with this airframe with regards to the auto land as incorporated in the latter versions of INAV, this being INAV version 8. But I have heard very good things about it, and it's something I'll get around to. I've been fortunate enough, only twice have I had the airplane return after it's been non-responsive. The remote's gone offline, and both times I managed to have a flyable airplane after we landed. So I was very comfortable with the performance of INAV in those circumstances. So again, just right now stretching the legs towards the bottom end of the battery pack, 3.5 volts or thereabouts. You have to bear in mind as you operate long range and as you come in situations like this, be prepared in the event of a go-around that you might be facing a brownout as your motor and your powertrain tries to draw any exceptional amount of amperage out of a pack that's at the bottom end, you might open the stop a little too much, brown out your flight controller, your VTX, and now either you are mindless or unable to see. And you know, that's the challenge. That's also where I have a problem with some of the VTOL airplanes. You know, the problem with an electric airplane versus a gas airplane in this circumstance is that, you know, airplanes burning jet fuel get lighter the further you fly, and thereby are able to power back in order to maintain their airspeeds. And you know, the specific fuel consumption per nautical mile finds you're stretching your fuel tremendously. With a VTOL, where you come into land and you maybe engage your motors at either a higher power setting or engage auxiliary lift motors as you're at the bottom end of that battery pack, you might discover that you brown out your control system, and it's something to bear in mind. So speaking of which, you can see the battery, you know, cell counter started flashing there as it crested through 3.4 or thereabout volts. The milliamp hour counter on the bottom left, I had that set at 1,000 milliamps, which I thought I would never reach, but again, that has not been calibrated. So now I'm really getting my head in the game, thinking about getting the airplane on the ground. Start flying some box patterns, lowering it down, bringing in, getting set up, feeling for my winds. I wish the winds were consistent out of any one particular direction, but they really were not. So here we are. We're basically coming in, starting our final approach. We're back in acro mode. You can see coming up here a little bit of battery sag. It shows the voltage is dropping off as I'm trying to extend my glide, and eventually I decide we're going to land a little further out in the field. And touchdown. It's a great little airplane. Hope you enjoy, guys. Well, that's it. I hope you enjoyed it. That's the Plank. I really enjoy this airplane. It's not conventional. It's a look that, you know, some folks like and some folks may not. I love its simplicity. I love its low parts count. I love its efficiency. It really fits a need for what I do in the flying that I enjoy. Stick it in the front seat of your car, backpack with a couple of batteries and your FPV goggles, and away you go. If it's something you like and you want one of these things, usefullaircraft.com. You can find the files on the website. I'm available through email there as well. If you have any questions, anything I can help with, be happy to help out. Any comments, thoughts, or questions, leave them in the comments below, and I'll do my best to get around to it. Anything you do to make any purchases to help support this, I sincerely appreciate it. It's a labor of love. I'm not trying to make $1 million on this whole thing. Honestly, I'm just using it to subsidize my hobby costs, but it means a lot to me. That said, this is a hobby that can be expensive, so do nothing else. Steal these ideas, turn around, improve upon them, make them better, and you know, I'd love to see what you turn out. I appreciate your time. My name is Brett. This has been Useful Aircraft. Thank you.